welcome to this class. As promised in the previous session, we said that we are going now to apply the properties of the laws of limits that we stated. And we say that there are a number of ways of finding or evaluating limits of functions. So the first thing that must always be on your fingertips before you start struggling to solve any problem on limits, the first method is to do what we call direct substitution. So if direct substitution doesn't work, is when you think about factorization, and maybe say using long division to carry out that factorization, or rationalization if you see some surds, and then L-Hospital's rule, which will be covered later. So let's start by examples. So evaluate. So the meaning of evaluate is the same as find. So evaluate or find the following limits. A, limit as x approaches 3 or 4x squared plus 6x plus 9. This one is not very hard to evaluate if you remember what we did, what we stated as the laws of properties in the previous session. This is the same thing as saying limit as x approaches 3 or 4x squared plus limit as x approaches 3 of 6x plus limit as x approaches 3 of 9. And then this by direct substitution will give us 4, 3 squared plus 6 times 3 plus 9. So 4 times 3 squared is 36 plus 18 plus 9. So that's 6 plus 18 plus 9. 6 plus 18 plus 9 gives you 63. And therefore the limit of this function 4x squared plus 6x plus 9 is 63. So one thing that you have to note from this one that which actually works in general, that limit as x approaches a of any constant k is always the same as that constant. Whatever the value of a you put there, always limit of a constant is the same constant, regardless of where you're approaching from. So that is the solution to that given problem. So this means limit of a constant is a constant, the same constant, regardless of where the x is approaching that value from. And then problem number two, limit as x approaches 5 of x squared minus 25 over x minus 5. So let's try to work out this by direct substitution. You see, this will give you 5 squared minus 25 over 5 minus 5. 5 squared is 25. 25 minus 25, 0 over 0. So division by 0 is not defined. So this is one, this undeterminate form. So we don't divide by 0. So therefore now we'll think about a different method of doing this one. Direct substitution doesn't work. So we say we factorize or we use factorization method whereby we'll have limit as x approaches 5. So these are difference of two squares. So x minus 5 and then x plus 5 divided by x minus 5. So after this factorization, the problem now becomes much simpler because this and this cancels out. So we'll have limit as x approaches 5 of x plus 5, and using the first property, they supply limit of some of these two functions. So we have limit as x approaches 5 of x plus limit as x approaches 5 of 5. And direct substitution, this will give us 5. We said limit of a constant is a constant. So 5 plus 5 is 10. And then number 3, limit as x approaches 1 of x cubed minus 1 over x minus 1. So this is C. This one, the first thing you try to do direct substitution. So direct substitution will be 1 cubed minus 1 over 1 minus 1. You see this gives us 0 over 0. Division by 0 is not defined. So therefore, I think about a different method, and this one will be factorization. So do what we call long division. And this is how we carry out long division. So you write the numerator x power 3 minus 1, and then you write x minus 1. Then you ask yourself, what should I multiply by x to get x power 3? So that's x squared. So write x squared here. And then x squared by this x cubed. X squared by minus 1 is minus x squared. And then just as with normal numbers, you will subtract. And then you subtract like terms. So x cubed minus x cubed gives us 0. And then on top here is like we have 0 x squared. It's like here we have here 0 x squared. So 0 x squared minus x squared will give us positive x squared. And then you bring this negative 1. What do you multiply by this x to get x squared? That will be x. So you say plus x. Now x by x is x squared. X by minus 1 is minus x. Then you still subtract. X squared minus x squared is 0. Now here it's like we have a 0x. So 0x minus x is positive x. Then you bring this minus 1. Ask yourself, what do you multiply by x to get x? That will be positive 1. So right here, positive 1. And then 1 times x is x. X times minus 1 is minus 1. And when now you carry out the difference, you get 0. So therefore, we'll have limit as x approaches 1 of x minus 1. Now, this time this one, x squared plus x plus 1 divided by x minus 1. And you see this one, this term and this one cancels out. So we'll have limit as x approaches 1 of x squared plus x plus 1, which will be now limit as x approaches 1 of x squared plus limit as x approaches 1 of x plus limit as x approaches 1 of 1. Direct substitution will give us this as 1 squared plus 1. Limit of a constant is the constant. So 1 squared is 1 plus 1 plus 1. And then we end up with our answer as 3. And then next example, say D. So limit as x approaches 0 of 5x squared minus 4 over x plus 1. So I said before you start struggling with either factorization or division, do direct substitution first. So by direct substitution, you'll have this one is the same thing as saying so solution limit as x approaches 0 of 5x squared minus 4 over limit as x approaches 0 of x plus 1. So limit as x approaches 0 of 5x squared minus 4x plus 1. And this will be the same as limit as x approaches 0 of 5x squared minus limit as x approaches 0 of 4 divided by limit as x approaches 0 of x plus limit as x approaches 0 of 1. So this will give us a direct substitution will be 5 times 0 squared minus limit of a constant is a constant divided by limit as x approaches 0, direct substitution give us 0, constant is 1. So this will be 0 minus 4 over 0 plus 1, so which is minus 4 over 1, which is just minus 4. So in the next session, we give more examples on how to evaluate limits. So thank you.